Let's look at part C, which is the final part of problem 3.01. And this problem is our introduction to using tables to finding state properties. Let's look at another problem involving water. This is water given as a temperature of 80 degrees C, and it has a quality of 0.75. X is the symbol we use for quality. Well, let's explore this. What is quality? We'll figure that out as we solve this problem. We're asked to find the specific volume at this state, and we want to plot it on a TV diagram. So if we come down here to the saturated water table, and what we know is its temperature is 80 degrees, so we'll use the temperature saturation table. And at 80 degrees C, we see that the saturation pressure is 0.4739 bar. So let's go ahead and plot that on our TV diagram. Here's our vapor dome. And I'm going to draw a horizontal line here through it, which represents the temperature that this state exists. So we know that we're going to plot this state somewhere on this horizontal line representing 80 degrees C. But we saw that the saturation pressure at 80 degrees C is 0.4739 bar. So let's also draw that line. Remember, a constant pressure line on a TV diagram goes up to the right. It's always horizontal under the vapor dome. So this is the pressure line representing this saturation pressure of 0.4739 bar. And that will cause this pressure line, at least the horizontal segment of it, to lie right on top of this 80 degrees C line. So here's the dilemma that we have. At the left side here of this horizontal section, when we have right here on the saturated liquid line, the temperature is 80 degrees C and the pressure is 0.4739 bar. In the center of the vapor dome on this line, the temperature is 80 degrees C and the pressure is 0.4739 bar. Now if I come all the way over here to the saturated vapor, the temperature is still 80 degrees C and the saturation pressure is still 0.4739 bar. So we can see that temperature and pressure are not independent variables when we're underneath the vapor dome. It's because all of these points, an infinite number of points, have the same temperature and the same pressure. So when we're talking about a saturated mixture, we use this quality property to describe where on this line it is. And the quality is 0 when it's here on the left side, when it's a saturated liquid, and it's 1 when it's all the way over here on the right side and it's a saturated vapor. So here's the definition of quality. It's defined as the mass of the vapor over the total mass, where the total mass is the mass of the liquid plus the mass of the vapor. Recall that a saturated mixture only has two components in it. It has saturated liquid and it has saturated vapor. Now, if it's mostly saturated liquid, it'll be under the vapor dome, but over here towards the saturated liquid line. If it's mostly vapor, it'll be over more to the right side, towards the saturated vapor line. So this is our definition of quality. It's the, and we can see that at a saturated vapor, where it's all saturated vapor, then the mass of the saturated liquid, m sub f, is going to be 0, and the quality will just be m sub g over m sub g, in other words, 1. So saturated liquid, or excuse me, saturated vapor has a quality of 1, whereas a saturated liquid would have no vapor in it, so m sub g would be 0 and the quality would be 0. Now we were told that the quality was 0.75, so I'm going to locate that on this TV diagram. I'm going to locate it on at this temperature and pressure about 3/4 of the way over, indicating that the quality is about 0.75, given that this edge of the line is 0 and this is 1. Now we can also come back to the table, to the specific volume columns, and we get the specific volume of the saturated liquid, V sub F, is 0.0010291 cubic meters per kilogram. And we see that the saturated vapor has a specific volume of 3.407 cubic meters per kilogram. Okay, and so the specific volume of this state is going to lie between these two values. And we'll look next at how to calculate that. Here is the equation for finding specific volume of a saturated mixture given the quality. The specific volume V is just equal to V sub F plus the quality times V sub G minus V sub F. In our particular case, we had a V sub F of 0.001. We had a quality of 0.75. And we had a value of V sub G of 3.407. And then we subtract our value for V sub F. And we get a specific volume of 2.556 cubic meters per kilogram. Now, and sometimes we'll find that we need to work this backwards, where given the specific volume, we want to know the quality. So if we take this equation here and simply rearrange it and solve for quality, we'll get that the quality is V minus V sub F over V sub G minus V sub F. So we will be using this, this form of the equation in the future.